Hello, this is Warren from Moreau. Today we'll be taking a look at Ubiquiti's TOUGHCable. Ubiquiti conducted their own reliability study, and what they found was that they received a 0.3% return rate on their products, which is very low when compared to other manufacturers. Of this 0.3% return, they discovered that the large majority of the failures were down to Ethernet ESD surge damage, and it was up to 80% of the failures were purely LAN port damage. Ubiquiti wanted to figure out why this was happening, and ultimately how could they prevent this from occurring. On a typical installation with a nanostation using a non-grounded PoE injector and unshielded Ethernet cable, standard Cat5 cable, the ESD sources can be the following. ESD, or electrostatic discharge or surge damage, can come via the outdoor network cable. So obviously this can occur with any nearby lightning strike. ESD can come from the AC mains, as well as the internal LAN. That is the third source of surge damage potentially. Whilst Ubiquiti products do have built-in ESD surge protection, these protection circuits are not infinite in their strike protection. What happens is, over time, these ESD events occur, and the protection that's built into the device gets reduced with each and every strike. It's not a matter of if the device will fail, but rather when the device will fail. The first thing that Ubiquiti did was to start shipping their own grounded PoE injectors with each and every outdoor product. This allows for electrostatic discharge, or ESD, from both the LAN and the mains to safely drain or discharge to earth via the mains plug within your home. This resolved two of the three sources of ESD damage. The outdoor source of ESD damage still remained an issue. Without a shield on the network cable, the equipment was still vulnerable to outdoor sources of ESD. In order to resolve this issue, Ubiquiti then developed their own solution in the form of TOUGHCable. You'll notice that the TOUGHCable features a foil shield and an additional drain wire. The connectors have a drain wire hook to make it easy to connect the drain wire to the shielded connector. This creates an end-to-end path to ground. Once crimped, both the foil shield and the copper drain wire are connected to the metal shielding on the RJ45 plug. The RJ45 plug will ultimately connect to the shielded port on your PoE injector or switch, which is in turn connected to earth. With TOUGHCable, you eliminate ESD-related Ethernet failures. The cable is built to withstand harsh environments. Of course, it's UV protected. The quality of the materials allow for improved network performance. This is thanks to the purity of the copper, and the fact that it's solid core copper and not CCA cable, as in copper-clad aluminium. Some manufacturers in the network cable only have a copper layer on the outside, as opposed to solid copper all the way through their conductors. Obviously, it's simply cheaper to have an aluminium core as opposed to copper. And the theory behind CCA cable is that the signal travels on the outside or the skin of the cable and not all the way through to the core. While this is true in part, it does ultimately have a negative effect on performance. Another benefit to this high quality cable and connectors is that you end up having extended cable run lengths, as well as improved power handling down to purely the superior conductivity of the cable and the connectors. By introducing TOUGHCable, not only is the indoor side of things protected, so is the outdoor. The shield itself is going to protect your network in most cases, and the copper drain wire is there purely as a backup or secondary line of defense. When ESD events occur, the energy will be conducted down through the PoE ejector to Earth. Ubiquiti tested their TOUGHCable solution in the lab. They used 50 meters of TOUGHCable, of course, one of their nanostations and one of their grounded PoE injectors. They used an ESD gun and zapped the cable 100 times with up to 35 kilovolts of power. That's 35,000 volts. The nanostation wasn't damaged at any point during the test, which ultimately proved, that their solution was 100% effective. The cable is going to be available in two versions. There'll be a TOUGHCable Pro, which is formerly known as level 1, and TOUGHCable Carrier, which is formerly known as level 2. Obviously the Pro and the Carrier are classified as Cat5e cable ultimately. Nonetheless, high performance Cat5e cable. We're going to take a look physically at the hardware itself and ultimately at the point of the whole exercise. Having a look here at the Pro version, you'll notice that the cable itself has a UV protected plastic outer housing. Obviously important for outdoor applications, as standard Cat5 cable will disintegrate over time when exposed to the sun. Underneath that you've got the foil layer, which provides the majority of the protection, the shielding to the cable itself. And then over here you have the copper drain wire, which ultimately attaches to the RJ45 connector, the TOUGHCable connector. Taking a closer look at the Pro version of the cable, the first thing that you'll notice is it has a very robust wire braid around the cable itself. Quite heavy duty, a lot thicker than most standard cables. Underneath that you have the obviously thicker foil coating, thicker than the actual Pro version. So here's the actual braid itself rolled up. You've got the foil layer, and thereafter, of course, the drain wire, which I believe is a slightly thicker standard than the Pro version, a thicker drain wire, which can only, again, help with earthing. And in the middle, you'll notice you have the divider. The purpose of this divider, and you see it a lot in Cat6 cable, is to separate the individual pairs, basically reducing crosstalk and ultimately improving data throughput. So we've seen the cable. Let's have a look at the RJ45 connector. Hopefully this is clear to you. As you can see, it's very much like any standard shielded RJ45 connector. The only key difference here is this connector for the drain wire. This loop, it allows you to attach the drain wire very securely to the connector itself. For some of you, you may actually want to solder this drain wire onto the connector for improved conductivity. Of course, this connector is of a higher quality than a lot of standard shielded connectors in terms of the grade of metal that goes into the pins. That obviously improves power handling and data transmission once again. The TOUGHCable connectors come in boxes of 100, although Miro specifically sells those individually should you wish to purchase them. Obviously, it's recommended that you use your TOUGHCable connectors with the actual TOUGHCable Pro and Carrier for maximum effect. Right, so I've pre-made a TOUGHCable with TOUGHCable connectors. I use the standard Pro cable simply because it's a little quicker to crimp. But as you can see, I have attached the drain wire. In fact, I've gone a step further, and as I mentioned earlier, I've actually soldered the drain wire onto the connector itself. And now we'll take a look at the effects of all the shielding and connectors. So I've got a standard multimeter with me here. I've put it into sort of the continuity test mode. So basically when I short the two terminals, I get notification of conductivity continuity. So if you have a look, I've got a standard 80 max gigabit switch here. You notice it's got a normal 3-pin South African grounded plug on it, and you'll see that it has shielded connectors. So if I attach one of the probes to the earth of the switch and then to the shielding, you'll notice that there is continuity there. There is basically a path to ground that would ultimately go into your mains to earth. So I've attached the Ubiquiti TOUGHCable. Here I have the other end of the cable, the connector. If I attach the probe here to the outside shielding of the cable, and again to the earth of the plug, there's a pass to earth. So by connecting this cable up to your radio, you essentially earth your radio. You don't have to run a separate drain wire or ground wire. So I have a Ubiquiti router station here. This is an example of any product really. It could be a nano station or any other third-party product. So connect up the top of the cable. Taking a closer look at the connector, you notice that it's a shielded connector. You'll see that the ground wire attached to the shielded RJ45. If I attach my probes to both the ground or earth on the 3-pin plug and to the shielding on the actual router station itself, I'm getting continuity or conductivity. So by having the system in place, you're earthing your equipment, and ultimately, instead of having an ESD surge pass through your equipment, because electricity obviously always takes the path of least resistance, it'll rather go around your equipment and safely to earth. Just another small feature of buying the Ubiquiti TOUGHCable product. Just in terms of the packaging, this is the carrier. Obviously with its more heavy duty shielding and so on, it requires a bigger box. It takes up a bit more space. But both the carrier and the Pro versions come with quick start guides that are attached to the sides of the boxes, and it shows you how to correctly strip the cable and ultimately crimp on the connector as well. It's a really small feature, but practically it makes a big difference to installers. The actual boxes themselves, the drum, if you will, that's inside the box, is on rollers, so that when you pull out the cable out of the box, it rolls out in a straight line. This is opposed to a lot of other network cable that's simply coiled inside a box, and as you pull out the cable tends to curl into sort of a corkscrew effect, and that's quite frustrating because you have to sort of unwind the cable and it tends to get into knots and that sort of thing. So when you actually pull on the cable, the drum rolls inside the box and it feeds out in a nice straight fashion. Thanks for watching.